Enumerated classes. Let's get the model right.
You are programming with Palermo. You deliver software. You need to move fast, deliver quality, and run your software with confidence. Stay tuned for timeless solutions, simple methods, and topics that will propel you forward. And now your host, lifelong programmer, author, teacher, coach, Christian, and charismatic speaker, Jeffrey Palermo.
Welcome to Programming with Palermo. We're going to talk about enumerated classes. Now, populating drop-down lists and multi-select lists has always been a challenge in interactive software. Some lists can be hard-coded because they really don't change. Male, female, yes, no, day, night. Other lists have, on the contrary, more dynamic nature, like states or regions of the country that the company services, or countries around the world. And some of the known options in lists can be required for business logic, whereas others are loaded from a database and it's just informational. We really don't have the code having any knowledge that one particular option is there. It could be totally different based on environments versus items in a list that have to be in every environment in order for the software to work. And so we're going to talk about the general options that you have to choose from and the characteristics of them and some of the architectural thinking when choosing which one. We're going to talk about how the Java enums are different from C# enums and why. We're going to go through the various options. Three main options we're going to cover today: C# enumerations, the enum keyword, enumerations, the C# enums with attributes to give more properties to your enums, and then implementing a design pattern to actually enumerate your C# classes. And we'll talk about the different reasons why you would choose one or the other. So let's get into it. So let's look at the matrix of options here. On the top, I have the different options that we're going to look at: an actual enum, an annotated enum, an enumerated class, and then another option, which is just using entities. You could obviously populate a drop-down list with a list of customers, but you would never hard code the presence of any particular customer in your system. Now, on user accounts, it is unfortunately pretty common to hard code a particular administrator account. At least historically, it has been. That's an old pattern that probably a lot of you have seen. But entities is another option. Now, if we look at each of the characteristics, starting with enum, if we want to add extra data to an enum, then we have to do it. We have to do it at the interfaces. We actually have to do it in the screens, in the UI, or in some code that uses the enum. And of course, when anything changes, we have to redeploy the software. When we add a new item to the list, we redeploy the software. With annotated enums, I'll show you in a second, it is a custom pattern, but when anything changes, we still have to redeploy. With enumerated classes, and we're going to hone in on this, we can update the data dynamically at runtime, and we can add new items to the lists. So let's look at code that might illustrate this. These are just regular enums, and I happen to have used a short instead of the regular int32, but you see father, mother, son, daughter, things that you might put in an application if you're tracking a family tree or whatnot. You can assign numbers, but they're going to implicitly be assigned. Now, the annotated method that I talked about is really just adding any kind of attribute to a particular item. So if we wanted to add a friendly name to some of these enums, then we could do that. Now, if we're doing father, mother, we might not see that we actually need to have friendly names that are formatable, but now we get down to great grandfather. We need to have a space in there, okay? So we see that, okay, friendly name is kind of required. Also, in a auction application, there's a enum where someone can bid by the head or they can bid by the pound. And of course, we have a friendly UI displayable name that has more spaces, that has changes in capitalization. And I want to kind of dig into this technique first. I like to illustrate everything with tests, and so we can run these tests and we can see that all these tests pass, so they're valid. But if we look at the usage pattern, bid type dot, we can see the IntelliSense is just a regular enum by the head, by the pound, and we can see that we have a extension method. This is not built into the framework. This is my extension method. I'll show you in a second. And the description string should be by the head, and it is. And so just let's go into, I'm going to hit Control B to jump into this with my handy dandy resharper shortcut. This is an enum extension. So if I show you where this is in the Solution Explorer, it's there. You can get the sample code again on my GitHub, listed in the show notes. And so toDescriptionString is really just running some reflection code, and it's getting the attributes and then combining them. So I'm not going to go through this code. Reflection code can always be a little nitty gritty, but it is a method for going through, finding the attribute, and then returning the value. Okay, you can look at the code in more detail if you're interested in it. But I have some more tests just to make sure that that works, and then some test enums down here. All right, so that is the attribute method. Along with this method, we need another helper, which is in this code called the enum option value tester. And in this case, we want to run these tests because, again, it's easy to illustrate things with tests to make sure that they're all valid. You can see we have one test should store description as name and should store enum as value. When we are going back and forth to a database in .NET, we're using Entity Framework, we're saving it in SQL Server or any type of database, we want to be able to translate and choose to store the value as the number or store the value as the name. And so in this case, we can translate back and forth using the friendly name if we want to, or the value. And given that these are attributes, these are compiled into the software. So if something's going to change, we have to recompile or redeploy the software, as well as any data that we might have used. Let's go to the next one, the Relationship Enum. And of course, we have some more tests making sure that this all works. And it does. We should be able to parse by name. We should be able to use annotations. And so we can see that we can use the relationship enum appropriately. The toString of father should be father. And then, of course, great-grandfather, the example that had a space in the name. We're going to go ahead and validate that. And just because sometimes it's very useful to have tests do some console output, there's that. We can see the embedded name and then the friendly name. So great with the space grandfather, and then we have the embedded name. So that works as expected. Now let's go to enumerated classes. So we're going to start with the test just as we did before. Expense report status tester. This is the status for a expense report, or think of a state machine or a work order application where you have some type of ticket, work order, expense report, and someone originally submits it, they draft it up, they submit it, it goes for approval, it routes to a few people, and it can be accepted, it can be in progress, it can be canceled, things like that. Any type of workflow system, you're gonna have some type of status for whatever the unit of the ticket is in the application. And so let's go ahead and run these tests, just because we always need to run the tests here. And we have one that is failing. And of course, I did that on purpose. So we're gonna change something. But before I dive into that, let's just look at the rest of them. So we're gonna ignore should accept loading friendly name from the database. Because remember, with enumerated classes, some of the advantages is that we can change the added properties at runtime, and we can add additional items to the list at runtime. Now, most of the time, you're not going to do it dynamically at runtime, just in the middle of the application. Most of the time, we're going to do it when the application starts up, or if we have a forced refresh event. Now, we're not going to do it on every screen load, every click. That doesn't make any sense. We're going to kind of load it up. We're going to cache it in the application, because this type of information, when we need it to change, is not going to be changing every second. It's going to be changing at defined periods that that particular business managers decide.
Programming with Palermo is brought to you by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient, moving fast, delivering quality, and running their software with confidence in Azure. If your team has a project that's too important to be delayed or derailed, ClearMeasure can help while keeping your team in the driver's seat and growing in capability. Click on clearmeasure.com for more information. If you are an architect or .NET engineer aspiring to become an architect, check out clearmeasure.com/careers. Now, back to the show.
So let's start with the friendly status. Of course, we want the syntax to look exactly like a particular enum, which it does. Expense report stats dot draft, dot canceled, dot approved, dot submitted. And then look, we have some additional methods. You can't put additional methods directly on an enum. You have to use extension methods. But we're looking at these icons. These are methods directly on it. And so if we go to a particular item and do a dot there, then we have properties, dot code, dot friendly name, dot key, dot sort by. Okay, so now these are looking more and more like entities or much more rich objects. Okay, so the friendly name should be drafting. The code of this particular value should be DFT. Now this is another advantage of enumerated classes. With enums, we can have a value that is an integer, that is a number. Whereas when we use enumerated classes and use this design pattern, we can add an arbitrary number of things, and a lot of times it's better to store some type of character code into the database rather than just a number. And of course, historically, databases that have been around a long time use status codes. They use letters or a combination of 2 or 3 letters, lots of different codes for things, not just numbers. And so this enables us to do that. If we're going to enumerate the values, I'm just going to run this test again because we're writing something out to the console. We can see draft has DFT and drafting, approved, APV and approved. So you can see the code and the friendly name there. And then if we want to parse it back from the name, we can do that. If we want to parse it back from draft, then we can do that. But look, this is really interesting. We aren't actually parsing it. We literally are taking a string and we are casting it directly to our type. Okay? You can't do that with the enums, but you can if you implement a full-blown type and then do some implicit operators. So let's run this, and we can see that that test passed. Now, this is the test that was failing. Let's look at why. We are loading things after the fact, okay? And of course, this right here is where it's failing. And it's failing because this is not true. We are saying, okay, draft, friendly name, and we're actually resetting it. And we're making sure that the object is the same as, and the friendly name should be pending draft. So let's run it again and see where it's failing. And you see it's drafting, but it's not pending draft. So if we click, then, this is actually the error, not the assert. All right, because I know what's going on, let me kind of show you the structure of an enumerated class. I'm going to actually go to expense report status. Now, I'm not going to go down to the bottom just yet because really the meat of it is right here, okay? Notice that we have private static instances of whatever items we need in our list, okay? I'm not going to go into detail here. You can look at the code. And then we have our actual instance variables of an instance of the object. We have a constructor and then a second constructor that is really used by us. And then we have a method getAllItems that gives all the items to us in the order that we want. And of course, if we've added any extensions, then we can do that. If you want to do an enumerated class and you're not going to allow for an extensions at runtime, then don't even have this concept of extensions. You can remove a lot of this code here. Again, this is your own design pattern, so take the code and suit it to yourself. We have some properties, and we have a few operators like equals. When we have enums, which are a value type, and we have a class, we want to emulate value type equals operations, and so we have our method for that. And I'm going to show what's interesting down here. Actually, I'm going to pass by the from code method. This is kind of like, hey, parse it from the code. It's pretty straightforward. Or parse it from a key, or parse it from a name. Those are all easy. But look at this. This is an implicit operator. This is a C# method that actually enables us to cast from a string to expense report status. And so whenever we have a string in code and we're trying to cast it to an object, if we did not have an implicit operator here, well, then the software wouldn't know what to do. But because we do, the string is passed into our method, we run the from code method, and then we get back the expense report status. So embedding things like this into your model makes all the code in so many different screens and areas of business logic all around your application. It gives them a really clean usage pattern by just concentrating this here. Okay, so let's go back up to the top and notice one more thing. I'm actually not saving instances. I'm saving methods or lambdas that will produce it. If I want to update the values of these on the fly, then I actually have to cast them. Right now, I'm not caching the draft instance. Every time we call draft, I'm actually creating a new one with our defaults. Let's go back to our tester. So if I want to be able to pull a draft instance and then update it, and then someone else pulls it and make sure that everything is the same and the friendly name is what I changed it to, then I actually need to cache that instance. So in order to do that, I change this from being a lambda, being effectively a small method, to saving that particular instance. So if I go back here and run this test again, now it passes because I'm actually keeping around the same instance that I modified. So that is enumerated classes. Several very feasible options exist for managing those drop-down lists and multi-select lists and applications. And each option comes with different capabilities and limitations. Before a change would require redeployment of the software, depending on what kind of change that you make. But you can kind of tell that I tend to go to an explicit design pattern pretty quickly when any of those forces start to manifest. Enums are great. Even enums, when you just need one more property and just let it be hard coded in the software, you can add those attributes. Once you add a few helper extension methods, again, you don't need to build those extension methods for yourself. Just go to the GitHub repository and you can snag those and tailor them to your liking. But anytime you have some business logic around some of these things, but at the same time, you need to display them on a screen or in any type of interface, whether it be an interface with another system by calling a web service, by sending a durable asynchronous message, or an interface with a person by putting it on a screen, or even putting it in a text message, email notifications, anything like that. Anytime you're elevating an enumeration into and through any type of interface, you tend to want to have it have some richer capabilities. And so it kind of becomes a value object inside your domain model, but then you use a particular design pattern that I've showed you so that that particular type of class can be enumerated. It is a fully fledged value object that'll belong to one of the aggregate roots, one of the aggregates in your domain model, but you need to do some special things just to make it enumerated, so that you don't have to have enumeration code and parsing code littered throughout your screens or close to your interfaces. Again, just like the tenets of onion architecture, you want to pull those concepts into the center, into the core, so your interface code, your code on the outside of your application is really, really simple to manage. So that's all for today. God bless. Thank you for programming with Palermo.
You've been watching Programming with Palermo, your primary place for highly productive programming protocols and practices. Remember, you have what it takes. You can do this. You are a programmer, formed by God Himself and called to this profession for a purpose. You can catch every episode at palermo.network, as well as syndicated locations nationwide. We're so glad you tuned in. Until next time, may God bless you, and thanks for Programming with Palermo. Programming with Palermo has made a special arrangement with Marketplace Chaplains. Besides programming challenges, we all face issues in life where we need some help. If you'd like, you can call a chaplain confidentially. To speak with a gentleman, dial 512-923-8178. Or to speak with a lady, dial 512-619-6950. The show won't know you called, and everything is kept in strict secrecy. This is a free service, available if you or a friend need it.